without further ado, Micah. Micah works at Ambition. So, what's your title? Your official title? You're a software engineer. Systems engineer. Web application security and you. Micah. All right.
Well, welcome. So let me jump to my slides. Play. So this talk is kind of split up into two parts. On the title, I think on the meetup page was OWASP Top 10 and penetration testing. So before I get to either of those, I kind of wanted to define a few terms. How many of you feel like you have an understanding of like web app security? Basic understanding. Basic, okay? So not many people, that's good. I feel like I have a basic understanding. I'm prefacing this. And maybe a little bit more, but I am not a penetration tester by trade. But I use some of these tools in order to test my own applications because it's really important. So we'll get started. What is security? I'll just give a formal definition really quick. It's protecting things like information, hardware, privacy, software, intellectual property, firmware, basically anything you want to keep from either malicious humans, malicious non-humans, like bots, acts of God. They happen. Unintentional, also humans. That happens a lot, right? Unintentional humans. Unintentional, non-humans, and acts of God. So these are things that you can readily think of, like the most obvious when you think of security is malicious actors. But also just as important is non-malicious people. Like what if your CEO has has write access to GitHub or has the ability to push deploy all? That's happened at our organization, and bad things have happened. So, and one other formal definition I'll go through. These are just basic sort of tenets and areas of security. You'll sometimes see CIA or CIAA. Confidentiality is just authorized user means authorized users are viewing authorized information. Integrity is only authorized users can add, change, or delete data. If you lose your integrity, non-authorized users can add, change, delete data. Availability, someone who is supposed to be accessing things can when they want to. If you lose availability, someone who's supposed to access things can't. Authentication is just tying a person to an account. A person is not an account. A person has an account. And accountability, so tracking what happens when and where. Most of the time this is done through logs. So logging becomes really important when you talk about security for an organization, for a web application. So this is just kind of a background on terms just to kind of get everyone on the same page. So in real life, we have OWASP Top 10. How many of you feel like you know at least 3 of the OWASP Top 10? Few people, okay. So the OWASP Top 10. OWASP is the Open Web Application Security Project. It's like a 501c3. And they basically say, here are like the top 10 things that websites do wrong or get hit with. So here's just the brief list. I won't go through every one because I don't really have the time or want to. But I'll just kind of briefly outline each of them. Injection. SQL, like this, typically what you think of with this is SQL injection. You have unsanitized SQL where you have a user can put in data and then it makes actions in your database you don't want. That's pretty bad. Broken authentication session management. That's like you have, say you set your session cookie on your application to never expire. Probably don't want to do that. That way, if that session cookie is ever compromised, it's never expired, and so whoever can use it whenever they want. Cross-site scripting, I'll get into that one in a minute. Insecure direct object references is pretty similar to missing function level access control. That's basically just like people can access things they shouldn't. If you think that it's safe to have a URL that performs administrative actions on your site, but you don't ever link that URL to a non-administrative user, but you don't put specific access controls on that, you might be surprised what happens. That is very often happens there. Security misconfiguration, it's pretty simple. That's just, you did things are configured wrong. Sensitive data exposure is, in their terms, typically like PII getting released, and that's oftentimes through, well, the way that they'll talk about it is breaking of encryption. That typically doesn't happen because it's pretty hard to break well-done encryption. More often than not happens is security misconfiguration, where you have good encryption, but there is some vulnerability in the library where some packet gets malformed, and then software can get overtaken. Cross-site request forgery, I'll get into that in a minute too. And then using components with known vulnerabilities. How many of you are completely sure that every piece of open source software you use is up to the latest security patch? Good. Nobody. Okay. Me neither. It's hard. It's really hard, but it's up here because it happens. Like Heartbleed, like that happened. And what hasn't been released yet? Who knows? Invalid redirects and forwards. Basically, you don't want to have on your site/redirect, and then put the redirect URI in the query, like to a foreign site, because that's, well, I'll get into that in a minute, but that's bad. We'll just leave it at that for now. You can view the full list, and I highly recommend reading through the full list. It gives really good examples and how to defend against them on the OWASP site. So homework, go look up the OWASP top 10 and just look even briefly through each of these. It'll give you a good kind of background. So cross-site scripting, XSS. How many of you are familiar with cross-site scripting or understand what it does? Okay, so a good amount. Cross-site scripting is where it typically happens where you return to a user data that they entered without sanitizing it. Similar to a SQL injection, except it's not affecting the database necessarily. Now we'll get to a demo really quick. Okay, I'll open this up in a second. I have two pieces of software here, just written in Go, and I'll show you the code really quick. Can everyone mostly see this? All right. So what happens here is this is just really, really, really basic, trivial, dumb example. But this is just serving one endpoint /account. And we're getting the query URI. I'll use the mouse right here. And saying hello query and returning that back to the user. This is bad because I'm not correctly doing this, and I'll show why in a second. So if I run that really quick, and I got to use a less secure browser. Don't use Firefox, by the way. It's bad. All right. So if I run this is talking to that server I just ran, and the query is chadev. So if I reload that, hi chadev. Now what happens if I drop in an alert, just a JavaScript alert? It's going to run. There we go. Pops up an alert. One of the reasons this is really bad is because, well, this is just an alert that says hi. This could be anything. And so if someone who's not from your agency puts a link to your site and your site is XSS vulnerable, they can not just put a script that says hello. They can put a script that does anything they want in a URI and then send it to any user who's legitimate on your site. If that user opens that link, boom, that your site is now executing code on the user's end that you don't want. And the reason this is really bad is, one, it opens up all kinds of things like it can make the user click things you don't want them to. It can make them, it can send out their session cookie. The list goes on and on, but that's basically why cross-site scripting is so bad. Now this is a trivial example. All right, okay. But that's just a demo to show like why that's so bad. So if we then go to, now I'll open a different one. So this is a second a server that's almost exactly like the first, except I'm only using a different library to execute my template, and it's Go's HTTP template library instead of just their text template library. Their HTTP template library filters out this kind of stuff. So watch what happens when I run almost the exact same server, just a different templating library. All right. In Firefox. Let's try this again. It safely sends in my script rather than executing it. So there's a lot more to this, but that's just a basic outline of like why XSS is really bad. So let's get back to the slides really quick. So cross-site request forgery is pretty similar. Basically, cross-site request forgery happens when a user clicks or executes a URL that you don't want them to. And that is oftentimes, but doesn't have to be, exploited along with a cross-site scripting. So you can have a user go to, basically, with a cross-site request or a XSS vulnerability combined with this, you could have a user end up performing all kinds of actions because this is not enabled. Really quick, I'm going to get to the defense. So basically, this stuff matters a lot, and I would encourage you again to look into like the details of these. But what I'm going to get to next is basically how to defend against these, how to check your own sites. And it really just starts with checking for vulnerabilities, because that's where you're going to find these. And I'm going to talk about two tools. So the first tool is called Zap. It's by OWASP. It's open source. It's on GitHub. And the links are right there. And so I'm going to show that off really quick. All right, start. So this is Zap. Can you all see this? And I have installed on my Firefox an extension that basically proxies all my requests through this Zap software to inspect basically every request I make. And then I can do more things with Zap. So I've started, I will in a second. Okay, so I have in the background a Drupal site running in a Docker container that has some vulnerabilities. So let's go to Drupal. All right, let's go to Drupal really quick. So this is our login. The login is brilliantly admin and password. Okay, so now we're in. Now that we've authenticated, if we go back over to Zap, we can see that like, hey, look, there's a boot to Docker, the URL we just entered, and the admin. And it also said, it also recorded everything we just did. So it noted, oh, there's a post. So let me flag this. as that's our login page. And the login parameter is name, and the password is pass, so it knows what to enter. And it's a form-based authentication. Okay. So now if we go to our context really quick, we can look at our users. We can add that admin user because it saved the password that we just entered. And now we can do all kinds of nasty things on the site. Attack. And now if, say, we wanted to first find what are web pages on this site without having to actively click through every site, that's called a spider. So let me select that one more time. Is that going to work? One more time. All right. So now what this is doing is you can see it's looking at every URL it can find and then finding links on every URL and following through on those and basically trying to build out a full site index of what is every page on this site that I can access. And it's reporting these down here. And it's also, I'll scroll back up, finding links to other sites down here, but it's just ignoring those for now. So we're going to stop that really quick. So that now that we found some of these pages, we're going to go through and attack this again, except instead of spider, we're going to do an active scan. Let's go something like that. Nope. So if we start a scan, we're going to start, we got a 403. So let me try that one more time. Let's go to the login page, which is right here. It's not working. So what you do with a scan is you start to build a profile of a site. So if we now go to alerts, we get to see, okay, what are the problems with this site? It's got X-frame options header not set. So that means X-frames option header is basically like, don't let me iframe this site. If I had that enabled, browsers would not let you iframe the site. That's bad because if I could iframe your site, I could put anything on top of it I wanted and have you clicking around on my site thinking you're on my site when I'm actually performing actions on your Amazon or on your bank account. It's not XSS protection enabled. Password is autocomplete. So these are just starting to identify a bunch of issues with the site. And that's basically where you start to get into, okay, what do I need to change? And that's where, look again at the OWASP top 10 because they have recommendations on how to defend against a lot of these things. So that's just kind of a brief overview of ZAP. There's a lot more tools to it, a lot more parts. And one other tool I'll show really quick, this is free and open source, which is really nice, is called Burp Suite. It's pretty similar. It's about $300 though, but it's got some really real niceties in terms of reporting and injection as well. So let me get out of this really quick. Exit discard. All right. So now I'm starting up Burp. This is just the free edition that's free. The actual commercial edition has a lot of the similar tools to Zap, but has like Spider and also shows you all the alerts on a site. So let's go really quick. So now we'll go to the proxy, turn that off. So now we see I just did a curl request and proxied it through Burp. And now I can see, again, that same site, boot to Docker, is right here. So now I can do things like spider this host. Spider, and now the spider's working, it's running, it's made 30 some requests. Oh, it's found a login form. Okay, submit form, let's try that. Submit that too. And so we'll pause that spider. And now we can look at this site again. And now these engagement tools are the pro version. They have things like find comments, code comments, find scripts, find references, analyze the target. And that analyzing is really important because in the scanner dialog, it would show you like the same thing we saw in Zap, where it shows you the alerts on each site. And it'll show you, oh, you have a pretty, it looks like you have a SQL injection like vulnerability here, or your cookie is not marked HTTP only, or all the same types of things that Burp would have, or that Zap would have. So that's Burp. It's very similar. Again, there's so much to cover with security that I really can't get into like all the parts right now, but those are just kind of the overview on protecting what are the issues and then how to defend against it, or how to detect before you can defend against it. Back to the slides. And yeah, that's about all I have. So does anyone have any questions? No questions? What's up?
If I wanted to use Zap,
Mm-hmm.
what would be the best resource for me, like learning the ins and outs of it?
They have their own demos with videos, and they have its own wiki on GitHub that kind of walks you through some of this stuff and like how to get set up, how to walk through like what's a spider, that kind of stuff.
So what would you recommend for continuous integration?
That's a good question. Zap runs on Linux, OS X, Windows, and it's scriptable. So you can add this to your CI, which is not a bad idea at all. It does, like, besides the spidering and the vulnerability scanning, it also does fuzzing. So fuzzing is basically putting a bunch of bad values in your forms, trying a bunch of things, just trying to see what breaks. And that's really a really important part of the CI too, is just like, okay, not just what am I vulnerable to, but passively, but actively.
Do you have a strategy and ambition for detecting and managing these kinds of security issues?
Yes. There's one thing that I haven't covered today, but there are a lot of good talks on, are basically like classifying issues. And on the OWASP site, they basically classify each of those 10 on basically how bad they are. And it's not just on a 1 to 10 scale, but like it classifies, okay, what's the business like severity? What's the data loss severity? What's the just organizational like PR severity? All those types of things. And that's where you can really basically classify like this is a really bad vulnerability because we don't even know who's doing this on us. There's no logging, there's no accountability to, it's like a mild annoyance. So is that?
Well, I think more what I was asking is there someone that's actually in charge of this? It's like, how do you, so you're in charge of this, like, is it like, it's not your full-time job, but
No.
like do you just like try to check every week?
Basically, it's not. We don't have it fully integrated into our RCI process right now. As part of we're in the Salesforce App Store, so we have just for that we have an annual review. But I also do this quarterly at least, just like a quick check on our sites and saying like, okay, this looks good. But again, this suite of things it's not like telling you that you're fully secure. It just tells you what you're not vulnerable to. When you find vulnerabilities and patch them. Because things like upstream packages that you're using, if you're not using the latest package, it won't tell you that.
So I know you showed the example earlier about the text versus HTTP, but from like a development and coding perspective, are there any like, real low-hanging fruit or top 10 or what you suggest as far as best practices go for developing these sites?
Really, the best practice is to be familiar with this stuff, like cross-site scripting and how it actually works, especially if you're a front-end engineer, because you need to know how you're sanitizing things. Are you just depending on the library to do it? If your library does a good job, that's great. But we were using a Django API library like a year ago that I was doing this testing on, and I was like, wait, we're getting XSS'd. Like, what's going on? And it was an upstream library that had an unannounced, or not even unannounced, unknown cross-site scripting vulnerability that I found and reported. So really testing it is super important.
Is there a good tool for suggest alternative if there is no vulnerability?
I mean, that's like, not, it really just depends on your stack. Like, are you using what language?
Like Bower, for instance.
Okay, yeah, like, I don't know really about JavaScript. There's one site that I've seen, I think it was Gymnasium. Yeah, Gymnasium, that basically does that for you. Like, I know it works with like Django and like Python packages and like Ruby gems. I don't know about JavaScript packages, but it would alert us to like, hey, there's a critical vulnerability out, or there's a like mild vulnerability out on this package. You need to upgrade.
So on the Ruby side of things, Code Climate does security scanning for
Mhm.
your
Okay.
client. I'm worried about that stuff. Is there something like that, like Python?
Not that I've found that's awesome, no. Anybody else? Cool. Well, thank you guys. Appreciate it.